We started a series on stoichiometry. We have taken part 1. This is part 2. If you must participate fully in this lecture, you must go to check up the video I made on part 1. Because without that, you may not be able to fully understand this calculation. Okay, I welcome you again to today's lecture. Please, let's follow up. We'll start with a simple calculation. You will need to give your mind and concentration to what I'm about doing so that you can fully grasp the methods and the skills, techniques that are required to solve problems on stoichiometry. So let's see the first question. 20 grams of calcium trisulcarbonate 4 reacts with 20 grams of HCl acid, dilute HCl acid. And then you are told to calculate the mass of the salt produced. Number 2, you are told to calculate the volume of CO2 gas produced at STP. You are given the equation of reaction, that is CaCO3 plus HCl to produce CaCl2 plus H2O plus CO2. I know you are familiar with this equation because this was the equation we used in part 1. So then CaCO3 and HCl are the reactants, while CaCl2, H2O, and CO2 are the products. Now, if you check the question properly, we are given 20 grams of CaCO3 and 20 grams of HCl. When you are given values for two reactants, it becomes a problem because we do not know which to actually use. We do not know if the reacting masses are given in appropriate, if the masses are in appropriate, given in appropriate quantity. And if we do not know if they are given in appropriate quantity, it means that we must determine which is limiting and which is in excess. You need to understand what a limiting reactant is. A limiting reactant is that one that is used up during a chemical reaction. It determines how far a chemical reaction can go. Once the limiting reactant is used up, the whole reaction comes to an end. The excess reactant is the one that is in excess of the limiting reactant. We do not use the excess reactant for calculations. So we need to now go and calculate the limiting reactant. We need to look for the limiting reactant. So let's see the steps to follow. Step 1 says determine the limiting reactant. How do we do that? How do we determine the limiting reactant? We get the equation again. CaCO3, HCl, CaCl2, H2O, and CO2. We must make sure that the equation is balanced. So let's see if it's balanced. Ca, one atom. Here we have 1 carbon, 1 carbon, 1 oxygen, 3. We have 3 here. And then we have 2HC, 2H, 2H, 2Cl, 2Cl. So the equation is balanced. Now we'll attack the question from the equation. So we say from equation, number of mole of CaCO3 to number of mole of HCl From the equation you will see you have 1 mole to 2 moles. Don't forget ratio. Another word for ratio is division. So the number of mole of CaCO3 to that of HCl is 1 to ratio 2. That's 1 over 2. If you resolve that, you're going to get 0.5 to 1. Then we go to the reaction. In the reaction, we're given 20 gram of CaCO3 and 20 gram of HCl. So we need to convert the gram, the mass given, to mole. How do you convert mass to mole? Don't forget that mole is known mass over molar mass. So we're going to use that idea here now. But we need to calculate the molar mass of CaCO3. So we're given atomic masses. For calcium, it is 40. For carbon, it's 12. For oxygen, it is 16. For hydrogen, it is 1. For chlorine, it is 35.5. So then, we calculate the molar mass of calcium trioxocarbonate 4. If you do that, following the number of atoms and the atomic masses given, we have 1 times 40. Just follow up through. That will give you 100 grams per mole. If you do that for HCl, you will get 36.5 grams per mole. So from the reaction now, number of mole of NCaCO3 to that of NHCl, that's number of mole of calcium trioxocarbonate 4 to number of mole of HCl, that will give us 20 gram, that's mass over molar mass for CaCO3, mass over molar mass for HCl. We're converting the masses to mole. If you divide appropriately, that will give you 0.2 for CaCO3 and 0.548 for HCl. Always give your answers to 3 significant figures. So remember, we said ratio means division, so we just carry out division here. That will give us 0.365 to 1. Now if you compare this value to this value here, you will discover that the one on top represents CaCO3, the one under represents NaCl. The one on top here represents CaCO3, the one under represents NaCl. So if you look at it now, for CaCO3 rather, it is 0.5. That means the equation is saying we need 0.5 of CaCO3 to 1 for HCl. However, the reaction is telling us that what we have is 0.365 for CaCO3 and 1 for HCl. So it means that we do not have enough CaCO3. Therefore, CaCO3 becomes your limiting reactant, while HCl becomes your excess reactant. Now, since we have determined the limiting and excess reactant, we can now use that to determine the mass of the salt produced. The salt produced actually is CaCl2. So we write the limiting reactant, which is CaCO3, and the salt CaCl2. Now from the equation, we see we have 1 mole of CaCO3 and 1 mole of CaCl2. 1 mole, 1 mole. Since we are required to get our answer in gram, which is mass, we need to convert the mole to mass. How do you convert mole to mass? You multiply the mole by the molar mass of the respective compound. So for CaCO3, don't forget we did that before, we got 100. So 100 times 1 gives us 100. For CaCl2, we didn't do that before, so by the side we did it as 1 times 40 plus 2 times 35.5. That will give us 1 grams per mole. And then we arrange it as follows. Don't forget this will give us 100, while this will give us 111. And so from the equation now, this is actually from the equation. Don't forget we started with 1 mole. We converted the mole to mass, to gram, and then that gave us 100 gram for CaCO3, 111 gram for CaCl2. And then from the question we're given from that's from the reaction, 20 gram will react with X. So we just cross multiply. When you cross multiply, the side facing what you're looking for will be used for division. That is 20 times 111 divided by 100. And if you resolve properly, you're going to get 22.2 gram of CaCl2. Then we go to the second question. The second question says the volume of CO2 gas produced at STP. The volume of CO2 gas produced at STP. So how do we do that? We use the limiting reactant again. The limiting reactant, that is, we use the limiting reactant to determine the volume of CO2 gas produced. So how do we do that? We get the limiting reactant. The limiting reactant is CaCO3 and the gas produced is CO2. Don't forget, from the equation we know it is 1 mole for CaCO3, and also from the equation 1 mole of CO2. Of course, don't remember that 1 mole of a gas occupies 22.4 dm³ at STP. Since we're converting mole to volume, we're required to get the volume of gas produced. So 1 mole, this 1 mole is equivalent to 22.4 dm³. And then don't forget, we're not given mole for CaCO3, we're given mass, which is 20 gram. So we need to convert that to mole. How do we do that? You just divide by the molar mass. We did that before. And then we equate that to X. If you resolve this, you get 0.2, still X. So this line and this other line are the same. So like we said, the side facing what you're looking for is used for division. So it becomes 0.2 times 22.4 divided by 1, since it is facing what you're looking for. And then when you resolve properly, you will get the volume of CO2 produced at STP, and that will give us 4.48 dm³ of CO2. Now, you would have to look at these exercises and see if you can adequately do them on your own. Let's look at number 1. Calculate the mass of sodium chloride produced when 5.85 gram of sodium reacts completely with excess chlorine gas. Now you have the atomic masses given. Don't forget, in the question we're told that chlorine is in excess already, so it means that the limiting reactant is sodium, because the question already told us that chlorine is in excess. So just follow through. Number 2, what volume of hydrogen gas at STP is produced when 6.5 gram of zinc reacts completely with excess dilute hydrochloric acid? Again, we're told that the dilute hydrochloric acid is in excess, so it means zinc is the limiting reactant. Question number 3, calculate the number of moles of carbon dioxide produced when 11 gram of calcium carbonate is completely heated. So I expect you to solve this problem. We'll meet in part 3 where I will solve each of these problems.